Um, in the last lecture, at the end of the lecture, we were discussing dimensional analysis. How many people have questions about this dimensional analysis? Did everybody study it and get it? Okay. Those of you who have some questions about dimensional analysis, who are not really sure what this is, please raise your hands. Do you get my question? Everybody, okay, thank you. So now I'll give you another example. Okay. Now, this example is from the notes. Okay. Now we know that when I drop something, it falls. Starting next week, we will learn how to treat this motion, how to get the formulas. At the moment, let's say we don't remember anything about this. We don't know any formulas. Okay? Which is always a healthy approach because we do not want to memorize any formulas. We want to be able to derive how things depend on each other in a simple way. So let's study this simple example. If I take my hand off, okay, this falls down. And if I observe this a bit more, I will notice that it falls down with a faster and faster speed. The speed is changing, so there is an acceleration. Okay? So I drop something from rest. It falls from height, yükseklik, h to the ground in t seconds. Okay. And let me remember that there is acceleration here, and the usual name for this acceleration in falling down is g. So let me call it g. But I don't know its value. I'm not concerned where it comes from yet. I don't know anything about it. Okay? Now, this time, how many seconds it takes for the object to fall to the ground from a height h will depend on some other quantities. What will it depend on? So the question is, I want to think about, figure out, how long does it take an object to fall down to the ground from a height h? This time in seconds will depend on what?
Speed of...
You say mass, okay? It will depend on the height, of course. If I drop it from a bigger height, of course it will take longer, obviously. And it will depend on acceleration. I don't even know it is gravity, but I observe that it's getting accelerated. So how long it will take depends on what is the acceleration. Because it depends on velocity. Velocity is changing all the time. So if there's big acceleration, it will quickly get to high velocity, so it will fall down quicker. But, of course, one of you mentioned a very good question. We'll talk about it a lot. I'm curious, maybe it also depends on this object. This object has a certain mass. So I wonder, I don't know the answer. I wonder if it depends on the mass. Çok yaşa. So here's our question. This time t will depend on g. It will depend on h. And it will depend on the mass. I forgot to mention the mass here. This something has mass. But actually, I've been saying it will depend. I don't know it will depend on it, but it may depend. You know, what is there to depend on? Okay, it may depend on the mass, maybe. It may depend on the acceleration, maybe. And on the height. And how will it depend on these things? Well, let me check that it depends on some powers of these things. And I'm checking this. Okay? So g to the power alpha these, for example, if alpha is 2, it's g squared. I don't know if alpha is 2 or 3 or 1/2 or what. Okay? Now here I start with dimensional analysis. The dimension of t is just time. It doesn't matter, you could say t, but when I talk about dimensions, I usually will use capital letters. Okay, so it doesn't matter. It's t. T will be equal to, now what is the dimension of g? G is an acceleration. Velocity is length over time. Acceleration is length over time, over time again, right? Because how much does the velocity change per second? Is this clear? Okay, so I put here L over t squared to alpha, power alpha, okay. And h, what's the dimension of h? Just n, right? It's just a length. And dimension of n is just n, okay? So this is n to the beta, n to the gamma. Okay? Clear? Okay, so now let's simplify this. This gives us t dimension of t actually. Well, I won't keep writing this dimension. You understand, okay? So L to the alpha plus beta, t to the minus 2 alpha because I'm dividing by t to the 2 alpha, m to the gamma. Now, this equality sign actually means dimensions are the same here. So I'm not writing the dimensions, but you understand that I'm talking about just dimensions. Okay? So now you can tell me what is the value of alpha? Because this is the trick in dimensional analysis. The dimensions of the basic quantities, how many powers you have, of course, must be the same on both sides of this expression. Okay? So what is alpha? Here I have how many powers of t? Just 1. So minus 2 alpha is